I'm Bill Ward, and I'm the engineering teacher here at West Florence High School. And we offer a variety of engineering courses, an introduction to engineering, principles of engineering, and we have our aerospace engineering. Aerospace starts off with they learn about the history of flight, how it came about. They learn about the principles of flight, such as the control surfaces. They learn about the pitch, the yaw, the roll. They also learn how to do the calculations for center of gravity, center of lift, which is the center of pressure. They learn how to calculate the lapse rates for the difference in the air pressure at altitudes, and about the different airspeeds, indicated airspeed, ground airspeed. They'll learn about navigation, how to do instrument navigation, navigation by radio. They'll also learn about propulsion systems, whether it be a propeller-driven gas engine, jets, different types of jets, turbofans, ramjets, all the way up to rocket engines. So they'll build gliders to learn about stability of flight, which is also great now where our flight simulator comes in, because after they learn and do all the calculations and learn all the math and theoretical stuff, now they can sit down and actually see it in practice, feel it with their hands, and watch it in action as they control and try to learn about it.
It helps you apply everything that you learn in the class, like the book stuff. So it's not like, oh yeah, I know this, but you just don't know how to apply it in a plane. That helps. The flight simulator is more realistic, so you can actually apply it.
We'll build rockets and launch those, and they'll learn how to calculate the altitudes and balance those. We'll even get to where they'll study and learn about the different types of orbits for satellites. Satellite orbits are very different depending on what the purpose of the satellite is for. They'll also then plan and calculate and map out a space expedition. Maybe they'll choose to go to Mars, and they'll have to plan out all the details of that. We also will build little satellites that will hang above the ground and take sonar maps of the surface. And they'll learn how to build surface maps like how satellites do when they go to other planets in orbit.
I learned how to calculate lift and drag with the different components that are a part of it. And I actually was the first out of the whole class to learn how to use the wind tunnel.
The wind tunnel's been an interesting tool for us. What they learn about is for flight is an airfoil, like what gives a plane its lift. So they'll learn the theories about it. Newton's 3 laws play an effect, Calandra effect, low pressure, high pressure, velocity type stuff. They'll learn all that, but then they actually they'll design their own airfoil in software. We take it into the 3D CAD software and manipulate it, print it out as a template. They create the airfoil, and then we put it on the wind tunnel and see how it works, compare its lift to drag ratios.
I didn't think planes had as much math as they do, but they have quite a bit. You've got your weight factors, your navigation, just like all types of angles and stuff you have to learn to fly a plane.
Here in a classroom, you can teach theories of flight. You can do the calculations, say, oh yeah, the numbers match, so it must be so. But until that's the closest we can get to actually getting in a plane. And for some of the students here, that is the closest they've ever gotten to being in a plane. Some students have never flown a commercial airline or anything like that. So when you learn how the theories work, the control surfaces of the aircraft come into play, and then they sit down and they actually have it in their hands. They're actually doing the fuel mixture, which you have to adjust depending on the ratio of air, because the higher you get in altitude, the less dense the air is. When they actually have to try to steer that plane, and they find out it doesn't steer the way a car does, because there's no friction to the pavement on the tires. You have 3 axes, not 2. They actually find out how it all comes together. There's students in this class that are not planning on being engineers, but they enjoy the learning and the activities that go about it. When you take an engineering class and you learn how to do the math, and for every theory we learn, there's a hands-on applied project, because learning the theories or how to do something is one thing, but how to apply it, how is it used to solve a real-world problem, that's where the engineering courses come in and the students learn.
For me, it's kind of, I don't really know what I'm going to do after school, and so it's a free way to try engineering and all the different parts of it with architecture and aerospace. So it's a really cool way to see if you're interested in it.
Today's world is very high tech, and everybody hears that. It's kind of almost becoming a cliche. It's said so often. But it's said so often because it's a real truth. And you know, you hear the national government, the U.S. government is now wanting to go back to the moon or even to Mars. And because when you have drives like that, it builds and grows technology. And our students here in Florence have got to compete in a global world. They're not going to compete in a Florence world, a Florence economy. It's a global economy, it's a global world. And Florence One School District is taking the steps to try and ensure our students have the courses and the equipment to compete in that.